Hello students, and on this clip we're going to be going over how to use the binomial theorem, and then we're going to verify our results with the Pascal's triangle that we've already gone over. So write on the title for this lesson: using the binomial theorem. Binomial theorem, or spelling. Theorem and Pascal's triangle. Pascal's triangle. Okay. So let's go ahead and take a look at some examples. Number one says, let's write down the instructions first. Expand the following using the binomial theorem. Okay, using the binomial theorem. Using the binomial theorem, and verify your coefficients / result, wherever applicable, using Pascal's triangle. Pascal's triangle. Okay? The only difference between the two methods is the generation of the coefficients before you expand the two terms on the inside in the binomial expression. So, number one, let's take a look at A plus B to the fourth. A plus B to the fourth. Okay? So, we're going to expand that using the binomial theorem first, and then we'll go on after that. So, just a real quick recap, we know what the binomial theorem is, right? The different renditions of that. You can use, it's basically the sum, and maybe write it here, the sum from r equals 0 to n of, we can put n factorial divided by n minus r factorial, and then times x, if x is the first one, x to the n minus r, y to the r. Basically, this is the expansion of x plus y to the r. Okay, and you remember this piece right here can be written as n r, same thing, and this is also the same thing as ncr. It's also the same thing as CNR. Okay, and there you have it. So that's what I'm going to apply with this one. Okay, so in this problem, you just need to remember that n is 4, and then r is going to go from 0, 1, 2, 3. It's going to go 0, 1, 2, 3, all the way to 4. Alright, so that's how it's going to work. So let's do it. I want to set up the coefficients first. I'm going to use this notation here, okay? I can use this anyone I desire to use, but let me just pick this one, right? So I'm going to, the first term is going to be 4, because n is always 4, n never changes. R starts from 0. 4 choose 0 is the first term. Going down, the next one is going to be 4 choose 1. And then the next one is going to be 4 choose 2. And 4 choose 3. And last but not the least, 4 choose 4. Okay? You end when they're the same. Okay, remember R starts from 0 and it goes all the way to 4. Alright, so now to populate the other parts using the two terms in my binomial expression, I'll just use the same trick we used before. Okay? A starts with everything, B has nothing. Alright, and then we start with the power switch. So A goes down to 3, B goes up to 1, A goes down to 2, B goes up to 2. Remember, the powers always have to add up to 4. A goes down to 1, B goes up to 3. A goes all the way to nothing, and B takes all the power. You see how the powers have inverted, right? So there you have it. Okay, so you can see the connection between this and the Pascal's triangle, right? Because everything else is the same. Only the method for generating this piece, that's what's different. Okay, so let's work this out. Using the definition of factorial that we have here, I'm going to apply that over here. So it's going to basically be 4 factorial divided by 4 minus 4 factorial. That's I'm sorry, 4 minus 0 factorial. 4 minus 0 factorial, 0 factorial, 0 factorial. And then we have a to the 4. Remember, that term raised to the 0, its power is just 1, right? So we just don't forget about that. Just have this left, okay? So this becomes 4 factorial over 4 factorial 0 factorial times a to the 4th. 4 factorial goes into itself. Please put the 1 here so you don't lose it. And then 4 goes into this one time. Okay? 0 factorial is 1 by definition. We went over that before. That's equal 1. So when I times this and this, it basically becomes a to the 4th. Okay? So there goes your first term. Next, I'm going to start skipping steps a little bit, okay? So I'm going to have 4 factorial divided by 4 minus 1 factorial goes here, which is 3 factorial, and then r is just going to be 1 factorial, and then times a to the 3rd b. Okay? I'm just putting 4 and 1 into this equation right here, so 4, 4 minus 1, and then 1. Alright? Okay, so now that simplifies into, I'm going to break down 4 into 3 factorial, and then go from there. So it's 4 times 3 factorial stuff divided by 3 factorial times 1 factorial is just 1, right? A to the 3rd b. Now this 3 factorials cancel out, and then when you multiply across, your final answer is 4 a to the 3rd b. Down. Alright, next one. And another thing is, you remember that this can be done with your calculator, right? Let me just review that with you real quick. But I want you to do it by hand for today's classwork, because I want to make sure you understand the mathematical principles behind the whole process, okay? You can just use a calculator for verification. So 4, choose 1, I can go 4, math, probability, so probability combination is 3, choose 1, answer is 4. Okay, so this whole thing is 4. That's why I got a 4 right there. So you can always use your calculator to do this part, but we're going to do it by hand today, okay? Alright, let's move on to the next term. So it's going to be 4 factorial on the top, because that's what n is, divided by 4 minus 2 is 2 factorial, and then r is 2 factorial, a squared, b squared. Alright, I'm going to break down 4 to one of these two. Since they're the same, it doesn't matter, I'll just break it to the first one. 4 times 3 times 2 factorial, and then I'll break down the second one, 2 times 1. Alright, 2 factorials cancel out. Let's put the a squared and b squared there. 2 goes into itself once, and 2 goes into 4 twice. If I multiply out, I'm going to have 6 a squared b squared. Alright, moving along to the next one, we have 4 factorial for n divided by 4 minus 3 is 1 factorial, r factorial is 3 factorial, and then a, b to the 3rd. Okay? Now I'll break down the top and stuff at the bigger and the bottom, which is 3 factorial, so I'm going to go 4 times 3 factorial stuff divided by 1 factorial is just 1 times 3 factorial, a, b to the 3rd. Okay? Now the 3 factorials cancel out, and you're left with 4, and your answer is going to be 4ab to the 3rd. Alright, last but not the least, we're going to have 4 factorial divided by 4 minus 4 factorial, 0 factorial, 4 factorial. A to the 0 is just simply, this is just simply 1 times b to the 4th. Okay? The 4 factorials cancel out right here because they're identical, right? So let me just write it like this. Just add one more step, okay? So it's 4 factorial, don't break it down. Over 0 factorial is 1 times 4 factorial, b to the 4th. And then this goes into self, please put a 1 here, and this goes into self once, times it across b to the 4th. Alright? So your final answer is a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab to the 3rd plus b to the 4th. And there you have it. Now, let's do the same problem using Pascal's triangle, and then we're going to compare and contrast. So let's see which one we prefer, okay? So a plus b to the 4th, if I wanted to use Pascal's triangle, I'm going to go to the 4th row, okay? So this is row 0, row 1, row 2, row 3, row 4. Okay? So we're just going to line up the numbers 1, 4, 6, 4, 1. And we play the game a to the 4th, b to the, put in parentheses, a to the 4th, b to the 0, a to the 3rd, b to 1, a to the 2nd, b to the 2nd, a to the 1st, b to the 3rd, a to the 0, b to the 4th. Okay? This one goes away to 1, I know that, and this one goes to 1, right? 1 also. So this one is just simply a to the 4th, 4a to the 3rd, b, 6a squared b squared, 4ab to the 3rd, and b to the 4th. Okay? So what's our answer? Our answer is going to become the sum of all these terms that we just generated from Pascal's triangle, a to the 4th plus 4a to the 3rd b plus 6a squared b squared plus 4a to the ab to the 3rd plus b to the 4th. Okay? Alright, so looking at the two methods, think about it. Which one do you prefer for this problem? Alright, welcome back, students. Now let's take a look at another example. Number 2. In this case, we're going to find specific terms, okay? So for this one, we're going to find the fourth term. Find the fourth term in the expansion of 2x minus y. Oh wait, let's do 2x minus y to the 19th. Alright, so for this one, you know what, let's pause on this one. I want to do this one later. So this is supposed to be my number 3. I kind of mix it up. Let's do this one first. So for number 2, let's do number 2. This one, find the middle term. Find the middle term of the expansion of 3x minus 2y to the 6 using the binomial theorem. Verify your answer. Verify your answer using Pascal's triangle. Okay, so we're going to use both methods, and then we'll see which one you guys prefer on this one, okay? Alright, so 3x minus 2y to the 6, we want to find just the middle term, okay? So I'm going to use a different notation for this one. So I'm going to start with the coefficients first. I'm going to go 6, C0, because we know that n is 6, and r is going to go from 0 to 6. Okay, that's what r is going to go. So this is n and this is r. So 6, 0 to start, and then it's going to be 6, 1, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and then 6 choose 6. And then the other side, we're looking for the middle term, right? So where's the middle term? First, second, third, fourth, fifth, sixth, seventh. So this is the middle term right here. This one is the middle. Okay. So in actuality, that's the only term I really care about. But let's set it up so we can get everything nicely organized. Alright, so I'm going to have times 3x. We're going to start doing the power switch game. 3x to the 6, and then negative 2y to the what? 0. So this one will start going down, 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 and this will start going up, up, up. So we're going to have 3x to the 5th, negative 2y. This one goes up to the 1. 3x goes down to 4, negative 2y goes up to 2. And this one goes down to 3, and then negative 2y to 3. Okay? I can fill this ones out, but I don't really care about those ones because all I need is a middle term, okay? I just need to expand this piece right here because that's the middle term, okay? Alright, so let's just focus our attention on this one and expand this one out. So it's going to become, using binomial theorem, it's going to become 6 factorial divided by 6 minus 3 factorial, using the formula, 3 factorial, and then 3 to the third, x to the third, because this has to be distributed to the x and the 3. And then the minus is being raised to an odd power, so the minus is going to come out, times 2 to the third, y to the third. Okay? Let's finish that up. So it's going to become negative 6 factorial over 3 factorial, 3 factorial, times 3 to the third is 27, times 2 to the third is 8, times x to the third, y to the third. Let's go a little bit further. If we break this down, it's going to be negative 6 times 5 times 4. Let's stop at 3 factorial over, keep one of them, let's keep this one, and break the other one, 3 times 2 times 1. And then 27 times 8. What is 27 times 8? 27 times 8 is 216. Times 216, x to the third, y to the third. And then let's start reducing this, okay? 3 factorial goes here 1, 3 factorial goes here 1. And then 3 and 2 is 6, right? So 3 goes here 1, 2 goes there 1. Both of them together takes this out. So we're going to have negative 20 times 216, x to the third, y to the third. Alright, when you times everything together, we're going to have 20 times 216, 4320. Okay, so our answer is going to be negative 4320, x to the third, y to the third. Okay, so you can see what took most of the time is evaluating this by hand, right? If you did it with a calculator, it would have been pretty much quick, right? It would have been quicker. But doing it by hand, this took some time. If I wanted to do this using Pascal's triangle, I just need to go to the 6th row, right? So let's do that real quick. Using Pascal's triangle, so using Pascal's, I'm just gonna go first row, second row, the first 0th row, first row, second row, third row, fourth row, fifth row, sixth row, Alright, so let's line up the numbers. 1, 6, 15, 20, 15, 6, 1. So the only one we care about basically is this one right here, the middle term, right? So the problem was 3x minus 2y. So it was 3x minus 2y that we're working with. 3x minus 2y to the 6th. So we're going to line them up here and do the inversion process. So let's see. So we have, you guys really do 3x, 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 and then negative 2y, negative 2y, negative 2y. I'm stopping here because that's the middle term. Okay, so this one goes from 6, 5, 4, 3. And this one goes from 0, 1, 2, 3. So this one's simply going to become 20 times 3 to the third, x to the third. Because of that minus, this becomes a negative, times 2 to the third, y to the third. Alright, and then it's simply negative 20 times 27 times 8. We already did this before. And then that's simply negative 4320. Because 27 times 8 is 216. We did that before. Okay? So you can see for this one, it looks like the pascals travel is faster, depending on what you think. Alright, let's try one last example, and then we're going to go ahead and start with the task for today. So we're going to do number 3 now, the one I gave up before. Number 3 says, find the fourth term in the expansion of 2x minus y to the 19. Okay? So to do this one, we're going to go, we know that n is 19. R is going to go from 0 all the way to 19, okay? But we need the fourth term, so we're going to stop at 3. So the first term is going to be 19, choose 0. The second term is going to be 19, choose 1. Third term is going to be 19, choose 2. Fourth term, which is what we want, is 19, choose 3. So this is our target. This is the one we want, okay? So let's set up the other part. So it's going to be 2x to the 19, 2x to the 18. Yes, 2x to the 17. So this one, the first one keeps going down, right? And then 2x to the 16. And then the negative y to the what? Starts with 0. Negative y goes to 1. This one starts creeping up. Negative y goes up to 2. And then negative y goes to 3. Alright? So our target right here is this one. So this is the only one we're going to expand, okay? So this is going to become 19 factorial divided by, if I subtract both of them, I'll have 16 factorial. 16 factorial, 3 factorial, times 2 to the 16, x to the 16, negatives and odd, so the negative comes out, times x to the third. Alright? So if I work this out, we're going to have negative 19 times 18 times 17 times 16 factorial stuff, divided by 16 factorial, times 3 times 2, and then times 2 to the 16. I don't want to do that. Let the calculator do that. X to the 16, x to the, what's that? Seems to be y. Y to the third. Okay? Alright, now let's see what cancels. So on the left side here, those two 16s go away. Just put the 1 there so we don't get confused. 3 and 2 is 6, so take both of them out. So 3 and 2 is 6. So 6 goes into 18 how many times? 3 times, okay? So we can cancel these 2, and then we go here 3 times. Alright, so times all this together, we're going to have, let me rewrite it. We're going to have 19 times 3 times 17 times 2 to the 16. Let's not forget the minus. Times x to the 16, y to the third. Alright, multiply everything together. and that will give us our result. So we're gonna have negative 19 times 3 times 17 times 2 raised to the 60th power. Boom. 63,504,384. Okay, so let's write that down. Negative 63,504,384. X to the 16, y to the third. Okay? Alright, now we're going to use Pascal's triangle. I'm going to have a volunteer come up and do 19 rows of Pascal's triangle for me. No, I was just kidding. It makes no sense, right? Thank you for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure.